today we're going to review how to graph tables of values, or using a table of values. So to start, you're going to pick values for x. It's totally your choice what you want to use for the x values. I tend to use just our regular -2, -1, 0, 1, and 2. Sometimes when you work with fractions, it makes more sense to use multiples of the denominator just so that you don't have to worry about fractions in the y values, but I'll show you that down on the on another example. When you pick your x values, then you sub those in to the equation. So my equation's up here as y equals 2x plus 3. That means I have 2 times my x value, which I sub in using brackets, so 2 times -2, and then we're adding 3, and when you calculate that, you're going to get -1. The next one, we're going to have 2 times -1, which is -2, but then we add 3, we get 1, and so on. 2 times 0 plus 3 is going to equal 3. And if you notice here, we actually have a pattern. These are going up by 2. We're adding 2 every time here. That really is our slope or our rate of change. And you'll notice that here in the equation, the 2 multiplies the x. That's the increasing amount. That's your rate of change, which you're going up by every time. So I can predict then that this next value here should be a 5, and then the next one should be 7. And then graphing these, we always graph our x first, so the horizontal axis first, and then the y-axis, the vertical axis, is second. So when my x was -2, I'm over at the -2 on the x, and then I'm going down 1, and I plot a point at that spot, so right about there. My next one is at -1, 1, so -1, 1 was this next ordered pair, came from this line here. -1, +1 would be up roughly here. And then we have 0, 3. 0, 3, this is a special value. It's called the y-intercept. And you'll notice on the equation that the number by itself, that constant term, when we talked about our definitions a few days ago, that constant term is the y-intercept. So we have the y-intercept at 3. We then have a 1, 5 for our next ordered pair. So 1 and then to the right and up 5. And then 2, 7. So over 2 and up 7. And I think I misplaced the previous spot there. Let me try that again. So the 5 should go here, and then 2, 7. And if I could use a ruler on here, it would be great, but unfortunately I can't. So even though I've only defined these 5 points, my line actually goes on forever and ever in both directions, and I could continue on creating more points. I would just line up my ruler there actually and be able to draw my nice straight line with my ruler. You want to put arrows on both ends, that's a communication piece, and you should label your equation with its name, which is y equals 2x plus 3. So those are communications pieces that I'll be looking for when I mark things. The next thing I want to talk about is the slope. Our slope really is also known as the rate of change. So I'm going to slide in here, rate of change. All right, our slope is also known as our rate of change. I think that looks good. Well, sort of. Oh, there we go. I'm learning new things on how to work with this. Its letter that we use to represent slope is the lowercase letter m. So I don't want uppercase, I want lowercase. M is equal to, gotta find an equal sign here, equal to, m is equal to, it's really a fraction, okay? And just because I might take a long time trying to figure out how to write a fraction using the keyboard, I'm just going to use my pen, and sorry about that. M is rise over run. So the slope is given by rise over run. We can always figure that out from a graph by using the scale and creating like a right angle triangle here. So I could go over and up. And that was really not so well done, but anyway, you've got your right angle triangle. The rise is this piece, the vertical part between any 2 points on your line. And then the run is the horizontal distance between the 2 points on that line. So in terms of the triangle I have, my rise, I started at 3 and I went 1, 2, 3, 4. So my rise was 4, my run was 2 blocks. Well, it was supposed to be 2 blocks, and that equals 2. So that was the slope that matches with the value in front of the x and also matches with our differences in our y's. So rise over run, it's also equal to the difference in the y values. So that first difference is really y2 minus y1, divided by the change in your x values, or x2 minus x1. Now I went up by ones on my table of values, so that made it easy to just say that the specific plus 2 was the slope, but that's because I'm really dividing by 1 on this side. These are my x2 minus x1s there. Slope is really it's a rate of change. It's also a measure of steepness. I'm going to go back to blue here. Okay, it's a rate of change. It's a measure of steepness in your line. We talked about in grade 9 that lines with positive slopes will always go up and to the right. Measure of steepness. Except I spelled steepness wrong. There we go. Measure of steepness. Positive slopes. So this is my short form for positive. A plus sign apostrophe VE for positive. Positive slopes will always go up to the right. Negative slopes. So again, my short form for negative is a minus sign with VE. Negative slopes will go down to the right or up to the left. If I have a slope of 0, if m is equal to 0, that's a horizontal line. And then if I have a vertical line, the slope is undefined. It's so steep we can't even give it a value because it's a measure of steepness. Slope is undefined. What happens is your run ends up being 0, and when you have a run of 0, you're dividing by 0, and you can't divide by 0. It just doesn't work. Okay, so we have that so far. Okay, and now we're going to review what is meant by the y-intercept and the x-intercepts. The y-intercept is where your graph crosses the y-axis. It's also known as our initial value. So let me see if I can put that in here. Your y-intercept is where the graph crosses the y-axis. Okay, it's also known as your initial value. So it's the starting fee when we're talking about cost questions. It's like the cost for the taxi cab to just come to your house. It's not even taking you anywhere. It's just $5 just for dropping or coming to your house to pick you up. That would be your y-intercept. That's the initial value. There we go. The initial value, y-intercept, if you notice in your equation, it's also the constant in your equation. It's that plus b piece in the equation. So it's the b in your y equals mx plus b. Let me see if I can get this back. Y equals mx plus b. Your initial value, I forgot the x. Your initial value is right here. It's the b value. All right, your x-intercept is where your graph crosses the x-axis. Those are also called the zeros. With lines, you should only have at most 1 0. You might have no zeros if you've got a horizontal line. But when we get into other kinds of graphs, our degree 2 graphs, our parabolas, we're going to end up with sometimes having 2 x-intercepts with those, or 2 zeros. So it's where the graph crosses. Where the graph crosses the x-axis. Okay, and they're also called zeros. All right. Now, we also know we can graph, I could create a table of values with this one, but I could also graph using the slope and y-intercept form, which is quite slick. It works very well. I'm looking at this equation. I know that the y-intercept is at -1. So that tells me I'm going to have my graph going through -1 on the y-axis. So this is my x-axis here. This is my y-axis. I should be labeling those. Now, as far as my slope goes, it's the number that's multiplying the x. So my slope in this case is 2/3. So my 2/3 is going to be a rise of 2/3. It's rise over run. So I know that from my point that I have at -1, I'm going to rise 2, 1, 2, and run 3, 1, 2, 3. They were both positive, so I'm going up and then to the right. And I'm going to rise 2 more and run 3, 1, 2, 3. I believe I'm right here at 6 and 3. Okay, or I really could make them both negative. -2, -3 would end up being positive 2/3. So I could fall 2 and go left 3, 1, 2, 3. So I could end up right here at -3, comma, -3. I could fall another 2 and then run 1, 2, 3. So I'm over here at -6, comma, -5. And then I would take my ruler and join these together, span the entire grid, put arrows on the ends, and label it with its name, which is y equals 2/3 x minus 1. Try the next one on your own, and then you can check it to see how you did. Okay, the next one should have a slope. This really is a +0. It has the slope of -5/4. That one should go up and to the left or down to the right. It has a y-intercept of 0, so it goes right through the origin. I'll talk about that in a moment. I want to fall 5. 1, 2, 3, 4, 5. I want to fall 5 and go right 4. 1, 2, 3, 4. I'm going to have a point here. Or, so I used it like this. I fell 5 and ran right 4. Or I could keep my 5 positive. I could go up 5, but then I'm going to go left 4. So up 5 and 1, 2, 3, 4 to the left. Okay, so I've got my points there. I'm going to draw a nice straight line with my ruler, if I could. And then I put my arrows on the ends, and we've got the name of it. Y equals -5/4x. There we are. Now, what I was going to mention here is when you have a line that does not go through the origin, just as a quick recap on that one, when it doesn't go through the origin, it's called partial variation. Something we talk about in grade 9, and then the ones that do go through the origin are called direct variation. So just keep that in mind. Direct variation through the origin, partial when it doesn't.